last time, I said that we would do a Fibonacci spiral this time. And I planned to show you that. But in looking at it, I realized something that was fascinating that I needed to share with you perhaps first. Maybe it's a mistake, but this is an abacus, and this is a smaller abacus. This could, because it has more rods, can do bigger problems than this. The abacus has 5 beads and 2 beads up above. This represents you've counted up to 4, and you've got this one down, which means 5. So this whole number would mean you have 9, 5, and 4. So the actual counting would have looked like this. 1, 2, 3, 4, 5. But as soon as you realize that you're going to be bringing the 5 up, what you do is you push these down and bring this down. There's 5, 6, 7, 8, 9. So I have a number here, a 6-digit number. This is 520. There's nothing in this. 520,000. 639. Now, this tool for helping one add and subtract made the people who mastered it be lickety-split at adding and subtracting. It's proved in time not to be as quick when you're doing multiplication or division. This originated in China, and there's a version in Japan. The version in Japan just has 1 bead up above. So this tool was making its way through trade slowly across Asia, made its way into what we would call the western part of Russia and some of the Balkan countries. But at the time that Fibonacci came along, everyone living where Fibonacci lived pretty well were still using Roman numerals, which is a particularly difficult way of showing larger numbers or adding really anything beyond maybe 50. One of the things that it lacked, which the abacus was able to show, is the Romans didn't have a place value, a 0. They had no way of showing 0. This, you see, we can show 0. So this tool's coming along to help Europe. But as of yet, it hadn't reached there. So I'll move it out of the way and show you why I even mentioned it. Last time, we had this bit of information. A sequence of numbers, 1, 1, 2, in which 2 digits are added together to get you the next digit. These 2 digits are added together to get you this digit. These 2 are added together to get you this. These 2 give you 8. 5 and 8 give you 13. 8, 13, 21. 13, 21, 34. And it continues on to infinity. Now, Fibonacci wrote a book which had a problem in it. The answer to the problem turned out to be this sequence called the Fibonacci sequence. The book was published in the year 1202. That's more than 800 years ago. And to give you some idea of how long ago that was, people were still using Roman numerals in Italy. He was born in Pisa, and during his lifetime, they started to build the Tower of Pisa. But it took them 200 years to complete the tower. So that sort of gives you a little bit of reference as to how long it took to do things back then. The other thing was that lots of times records weren't kept as accurately as they are now, or records in the time, those 800 years, some were lost, some were destroyed. So we don't know exactly when Fibonacci was born. It's estimated around 1175. Nor do we know when he died for sure. Again, it's estimated at 1250. So Fibonacci, as a youngster, went with his dad, who was a merchant. He went to northern Africa, and there, in northern Africa, he came across the Hindu Arabic number system, which wrote numbers like we do, 1, 2, 3, 4, 5, 6, and had 0. And he learned that and felt that it would be extremely useful, brought it back, and in his book, that one in 1202, advertised it, promoted it, and so that it became embraced by people in Europe, merchants in particular, to keep track of their business dealings. And it's proved to be an asset to, well, certainly commerce. Now, I don't know, and in my research I couldn't find where anybody could tell me when this sequence of numbers was used to make what's known as a Fibonacci spiral. So sometime, maybe in his lifetime, or if not in his lifetime, certainly after his lifetime, somebody realized that if they used this sequence, they could make a neat spiral. So let me show you an example. Now, I'll use my pencil to help. The spiral uses squares. To create the spiral, you have to have squares. And the first square is a 1. And the next square is a 1. And then 2 squares by 2 squares, a 2 square, a 3 by 3 square, a 5 by 5 square, an 8 by 8 square, a 13 by 13 square, a 21 by 21 square, and a 34 by 34 square. Now, this graph paper is got squares in it that are 5 millimeters by 5 millimeters. So they're fairly small square. And I've given a little margin at the top and a little margin here. And I started by drawing a line across and a line down. And then I counted the squares not the lines, but the squares. So I wouldn't get confused, because I want to be sure to have 21 squares. And once I had 21 squares, I drew a line across. I didn't know quite how far to draw it across. So I counted down here, or I could count up here till I had 21 squares. And then I drew a line down. I didn't know quite how far down to go. Well, I did know it was going to be 13 down. But I've got this square to start with. And I took my compass. I put my metal point in here. I opened to my pencil point here. And I wanted to be sure before I did anything more than this that I had this square correct. And one way to find that out would be to draw this arc. And if the arc went above, or if it ended up one square below, then I didn't have the right number of squares. But this turned out just fine. So I was ready to go to this place. I want my arc to connect. So it's going to need to have a square that'll be right next to where it's left off. So I count down my 13 squares, and I draw a line across. And I count across 13, and I draw my line up. Now this time, I'm going to put my metal point in here, open my compass point to here, draw an arc to be sure that I've done that okay. Yes, so far so good. So the next square is going to be an 8 square. And since I've drawn this line down, I hope to find that I've got 8 here. So I do 1, 2, 3, 4, 5, 6, 7, 8. Good. So 8 up. Make that square. Put my metal point here. Open it this distance. Make my arc. Then I'm going to have a 5 square. Metal point here. Make my arc. A 3 square. A 2 square. And for the last 2, I just sketched them in. Having the compass that small together is really hard to make it work. So I just sketched it in freehand, sort of recognizing the way those arcs went. Okay? So I'm ready now for my last arc. It'll come down this way. But I count, and I find I have a problem. It's the first of several problems. I find that when I count, I've got, if I counted right past the edge there, I have only 31 squares, and I needed 34 squares. So I have several possibilities, I guess. One is, that would mean if I drew the arc, my metal point here and my pencil point there, it would go off the page somewhere over here. Well, I know that there are shells, for example, that grow in spirals. So this would be, the shell is growing. It just hasn't completed it. So I would be okay with that. So I say, okay, let's move along. I get my compass. I open it all the way that this compass will go. And I put my metal point in. And lo and behold, I can't get it to be large enough to make that arc. So now I'm stuck. Unless I happen to have another compass. I've got several I've gotten over the years. Maybe one would be big enough to do that. And I put in the metal point. Oh, yes, this one will certainly do it. So I put that there, and I can now draw the rest of my arc. And it does go off the page right there. I have some more paper underneath, so it's maybe a little hard to see, but it goes off the page right about there. So, I remember I told you a long time ago that you could create arcs by using string. So I've got some string here. Obviously I've found that this might be the solution, or I wouldn't have had the string here. But let's wrap the string around it a bit, hold it with my fingers down near the pencil point, hold it with my fingernail right there, get it to this distance, and then merely start to move it along. Now I wanted to show you this because I'm going to show you something where the only way you're going to be able to get an answer would be to use string. So it does go off the page right about there. But there's the Fibonacci spiral. That's what it looks like. Now, let's say I didn't want it to go off the page. So I thought about that a little bit, posed another problem to myself. If I didn't want it to go off the page, what might I do? Well, I'm thinking, each one of these rectangle shapes is sort of just a smaller version of this rectangle shape, which is a smaller version of this rectangle shape, which is a miniature version of that rectangle shape, which is a miniature of this rectangular shape. They're all similar rectangles. So I'm thinking, you know what? I think I could just not put this on at all. I could just put this on and use graph paper with bigger squares than 5 millimeters, because in some places all that you might find is what's known as 1/4 inch graph paper. So here's a piece of 1/4 inch graph paper, and I decide I'd like to center this on the page. So I'm creating problems for myself, saying, where would this fit on the page? Well, I know that to get this far out and down, I am going to need, in fact, let me draw this line. Now I'm going to do something here when I draw this line. I'm going to draw it. I'm just going to draw it like this. I'll show you what I had in mind in a second. All right. And this will demonstrate the Fibonacci spiral up to, this must be 21. Now, if this is 21, this is 13. At 13, the next number is 21. 3, 5, 8, 5 and 8 is 13. 8 and 13 is 21. So 13 and 21, the total of that is 34. We know that, Larry, from the Fibonacci spiral, 13 with 34. And I counted the number of squares, and I found I had 42. I wrote it down because I would have forgotten. But I said 42, if I took 34 from 42, I'd get 8 squares. So I could have 4 squares here and 4 squares there. I also see that this 4 full squares and then part of a square, and 4 full squares and part of a square. And I also notice on this paper that let me just move it away from that, you can see it more easily. The squares aren't quite exact. The paper was cut sort of at a slant, because here I've got full square, a few of them, and then they end up being maybe half a square, and the same down here. These are not full squares, but they're bigger than what they've got over here. So it's not perfect. Well, let's see. I want to center it this way. Now, what did I have? I had 21. Well, I count those squares and I found I had 33. And I said, that's fantastic. 21 from 33 is 12. So I could have 6 on top and 6 on the bottom. But then I got thinking, all right, I would like to have maybe enough room that I could write in sort of big letters in a couple of the squares, and Fibonacci, F-I-B-O, Fibonacci spiral. Well, I'm going to leave a little more at the bottom and less at the top. So I made it 4 at the top, and I made it, what did I say? 6. I added the 2 from the top to the 2 down here. Okay. So if you pause on the other things and you work it, you'll get this to work out just fine. Just do this corner first with whatever one you're going to have there. In this case, it's the 13. But, I said, I wonder if, since there's 33 and I need 34, what would happen if I took another piece of graph paper and turned it over? Let's see. Yeah, this is blank on the back side. Turn it over, and I put tape along this side and put another piece there so that the tape went over both of them. And I now had enough to put whoa. In other words, I could extend, and that's what I'd started to do, I could extend this line right here and link it up to the next page and extend this line. And then when the time came I put my piece of string and hold it down here and my pencil here and hold it on, and then just pull it around, all the way around. Well, I said the Fibonacci sequence goes to infinity. This spiral must be able to go to infinity. So I could take 2 more pieces of graph paper and put them on here, or maybe I would need 4 pieces and make my spiral go that way using the string and my pencil. Make big curve and maybe make it so big I could put it up on the wall. This huge spiral. Fibonacci spiral. Well, next time I'm going to show you the way some students colored theirs in, and a few more little things off the track a bit, but there will be a design next time. So we'll see you then. Bye for now.